Okay, so where we left off. So now we want to find the equation of the tangent line for this problem, and we want to find it at the leftmost point. What was that leftmost point? Was it negative 1/2? Okay, so negative 1/2. What's the other part? 1/2. 1/2. All right, so slope of the tangent line is limit. I'll write you a note. Of f of x plus h. You have a test first, Howard? No. Over h. Okay, so then it's going to be the limit as h approaches 0 of f of x plus h. So let's figure that out first. So we're going to plug x plus h for every x in that equation. So it's going to look like this. Negative 2 times x plus h squared plus 2 times x plus h plus 2 minus f of x, which would be negative 2x squared plus 2x plus 2 all over h. Okay?
The x squared negative 2.
Oh yeah. X squared right there. Thank you. All right, extend the page. All right, so now we're just going to evaluate this limit, and this is going to calculate the slope of the tangent line. So we got the limit as h approaches 0 of, so it's going to be negative 2 times, if you FOIL this is going to be x squared plus 2xh plus h squared. Then it'll be plus 2x plus 2h. Then it'll be plus 2x squared minus 2x minus 2 all over h. So then we have the limit as h approaches 0. Distribute the negative 2. We got negative 2x squared minus 4xh minus 2h squared plus 2x plus 2h plus 2x squared minus 2x minus 2 all over h. Now things should start to cancel. The x squareds cancel. The 2x's cancel. Why aren't the 2's canceling? Because I forgot the plus 2 right there. Forgot to bring that plus 2 down there. It's a good lesson to learn. So that plus 2 would also get brought down here. And now it cancels. Okay? So be careful. See, I said that yesterday. It's so easy to forget a constant or something like that. So now we have the limit as h approaches 0 of negative 4xh minus 2h squared plus 2h all over h. And what can you do now? Factor out a h. So we have the limit as h approaches 0 of h times negative 4x minus 2h plus 2. So now we cancel the h's. Now the h is gone from our definition of our derivative. So now you can plug 0 in for h, which means if I do that, this is going to go to 0. So we're going to have negative 4x minus 0 plus 2. So it's going to be negative 4x plus 2. This is your derivative. This is your slope of your tangent line. So I'm going to remember that. I'm going to go back up here. So negative 4x plus 2. So let's bring this back up. The board's still acting slow. So anyway. Alright, so there we are. So my slope of my tangent line then, stop now. Of course it's not going to stop. It's going to go past where I want to go. And so, my slope of my tangent line at the leftmost point. Okay? So it'd be, stop, board. Are you kidding me? Just give me the point. What was it? So my slope of my tangent line, which is also my derivative, which is f prime of x, is equal to negative 4x plus 2. Now they wanted me to find the equation for the tangent line. So whatever this parabola looks like, it's like an upside down parabola. And they have a point, what was it, negative 1/2, 1/2. Wherever that point's at, negative 1/2, 1/2, wherever it's at on the graph, there's a tangent line. Good morning.
Trying to throw off the ball.
Yeah, I need to. Well, this is the other brother. He's
Oh, this is the other brother.
This is the hockey guy.
This is how to put it in the net.
Yeah. With a little bit of calculus.
Yeah.
So. Yeah. So.
How'd you make that circle move like that?
My hand. Cool.
Mark, you got such stuff.
I do. So now you find the slope of the tangent line at this point. So all you got to do is plug in the
Excellent.
x value. So f prime of -1/2 equals -4 times -1/2 plus 2, which will give you a positive -4 times -1/2, so positive 2 plus 2. So therefore, f prime of -1/2 is equal to 4. So there's your slope of your tangent line. That's what that calculates. That's what the derivative does. It calculates the slope of the tangent line at specific points. And you just have to plug it into the equation that calculates the slope of every tangent line on the graph. Now you just take your point, run a 2-point slope form at the leftmost point. So you can't choose the other one now. It's only one point that we have on a tangent line. Y minus 1/2, we don't know another point on the tangent line. We only know that one because it only crosses that graph in one place. And then it'll be 4 times x plus 1/2, and again, probably set it equal to y, so it'd be y minus 1/2 is equal to 4x plus, what would that be, 2, add 1/2, and that'll be y equals 4x, what's 2 plus 1/2, that'd be 2.5, which is what, plus 5/2. And there's your tangent line equation. Okay, does that help? And you do the same thing with the next example, which I'm going to go ahead and do, but you guys can watch and pause. So for the next one,
Now you're gonna know.
yeah, just get a piece of paper and yes, write it, I'll sign it. So for the next one, you want to find the average rate of change and the instant rate of change at the leftmost value. And this is exactly the same thing as the problem before, but they're using different terminology. But average rate of change just means slope of the secant, and an instant rate of change means slope of the tangent. So this is 9th grade slope, and this is derivative, which is senior high, what we're doing as calculus slope. And so, but here they're only asking for this slope, so we don't have to do equations. So let's start with this one, average rate of change, and they give you an interval this time. So I actually have to find out what those points are. So I'm going to find y of -4. So I'm going to plug -4 in, so it's going to be the opposite of -4 squared minus 2 times -4 plus 2. So that'll be -16. As you square the -4 first, make it 16, then it becomes -16 plus 8 plus 2. And so it'll be -8 plus 2, which is -6. So we got y of -4 is equal to -6. And then we go y of -7/2 is the opposite of -7/2 squared minus 2 times -7/2 plus 2. So that's going to be -49/4. This will be plus 7 plus 2. And if I want a common denominator, that's going to be -49/4 plus 28/4 plus 8/4. So let's see, what would that be? That would be 36/4. Yeah, or no, that'd be, 36/4. So we got -49/4 plus 36/4, which would be -13/4. So there's that point. So we got a point, so to find the slope of the secant, it's just f of b minus f of a over b minus a, which is y2 minus y1 over x2 minus x1. So slope of the secant is going to be f of, or y of, it doesn't matter, y of -7/2 minus f of -4 all over -7/2 minus a -4 Now we calculated these just a second ago, so that would be negative 7/2 would be negative 13/4. So we're going to negative 13/4 minus negative 6. So it's going to really be plus 6 all over. Down here on bottom, we can go ahead and do this with a common denominator. The 4 would become 8/2, so it would be negative 7/2 plus 8/2. The top, the common denominator would be 4, so I'm just going to change that right here and right over top of it. That'd be 24/4. Same thing as 6. So what we're going to end up with is, let's see here, drum roll, that'd be 11/4 divided by 1/2. Then I multiply by the reciprocal, which is the same thing as multiplying by 2. So we're going to have 11/4 times 2 over 1. 2 cancels, so we're going to end up with the slope of the secant line of 11/2. So there it is, slope of the secant line of 11/2. Now instantaneous rate of change at the leftmost value. So that's the negative 7/2, negative 13/4. So I'm going to go, that's negative x squared minus 2x plus 2. Negative x squared. So it's negative x squared minus 2x plus 2. So I want to find the slope of the tangent. So to do that, then I want to find it at the point at negative 7/2, negative 13/4. So I'm going to do that. It's the limit as h approaches 0 of f of x plus h using this equation. So I'm going to go negative x plus h squared minus 2 times x plus h plus 2 all over, or no, hold on, minus, so that's your f of x plus h right there. Now it's minus f of x, which is negative x squared minus 2x plus 2, and then it's all over h. So then we get the limit as h approaches 0 of, let's see, it'd be the opposite of x squared plus 2xh plus h squared, in parentheses, minus 2x minus 2h plus 2 plus x squared, distributing the negative, plus 2x minus 2 all over h. So that'd be the limit as h approaches 0 of negative x squared minus 2xh minus h squared minus 2x minus 2h plus 2 plus x squared plus 2x minus 2 all over h. And then what happens here is your x squared, you collect like terms at this point. Your x squareds cancel, slash and burn. 2x's cancel, the 2's cancel, and we should be left with everything has an h in it, and it does. So we'll extend the page here. Don't forget our point, what that is. So we got the limit as h approaches 0. Now we've got, factor out an h, we're going to have negative 2x minus h minus 2 all over h. H is canceled, plug in h equals 0, and we got negative 2x minus 2. There's your slope of your tangent, that's your derivative. Now if I want to find the derivative is negative 2x minus 2, which is the slope of the tangent, and I wanted to find it at the leftmost endpoint, which was this point, and so I'm going to go f of negative 7/2, because I just need the x, it'd be negative 2 times negative 7/2 minus 2, so that's going to be a positive 7, because the 2's cancel, negative times a negative, minus 2, and that will give me a slope of 5. So that's the slope of the tangent line at that point. There you go.